this side. Great. Excited to see all of you. Folks, so today we're going to be working with a little bit kind of that intro or that first dip into understanding what feature or what data engineering kind of looks like. In a lot of ways, what we're doing is we're taking data from multiple sources and beginning to understand how to combine them together and how to work with them in an aggregated method. I'm going to start off with a brief anecdote. I love some of the stories that you've shared on Slack, so keep them coming. It's great to see where that engagement is coming from. I am beginning to. What's interesting to see is that since I started doing this as a career, I do tend to ask that question a lot. So it's really funny to see how much people's emphasis on data has really come into fruition over the last 2 years, because you're all absolutely right. The last 2 years have been very much data driven and data visualizations and graphs and all kinds of COVID related, a data driven approach to understanding what it's like to live within a global pandemic. So it's nice to see, it's unfortunate, but it is nice to see how that has kind of spurred an interest in how data affects our day-to-day life. So kudos to those of you who want to take that approach. Unfortunate that it, yeah, we all know, right? But before we get started, I would just want to quickly address a couple of administrative things. This Thursday, starting really Thursday at 5 p.m. and going throughout the entire day on Friday, you'll have your first sprint challenge. Now, as a reminder, much like your module projects, you'll be given a percentage score on that sprint challenge. Now, in order to pass a sprint, you need to remember that you need to score a 5 out of 5. Now, the sprint challenges are intended to be a summary and a review of the content that we've done so far. So it should not necessarily be too much of a, it's not intended to be impossible to get in 100%. As a matter of fact, if you've been getting a 5 out of 5 with your sprint challenge, with your module projects over the last few days, you should find that it's relatively easy. As a matter of fact, if you're finding yourself comfortable navigating code grade, seeing the values and seeing what your output looks like against the residual answers on the auto grade, if you're comfortable navigating this, your sprint challenge on Friday should be no problem at all. If indeed you're still having trouble, if you're still not sure where to see the answers on AutoGrade after you've submitted your problem, if you're not quite sure how to navigate that, please make sure to book some time with me through our Calendly link. This is something that you're going to need to know from the get-go in order to do well on the sprint challenge. Couple things, if you are looking for either the Slido link or any of the Zoom link, I've actually gone ahead and just bookmarked it because obviously it made sense to bookmark the Slido link. So that's going to be available on the Slack channel from the very beginning. Now, a couple other things. We also have additionally a study guide that you can use for your sprint challenge if you want to do some additional work in that with the work that we've done so far. So if you click on the study guide, we have a short summary of the things you're going to want to think about how to use. This is more of a general set of resources that you can use to learn some additional tools with Python, Pandas, and the Seaborn library. But a specific Jupyter notebook for review with our sprint challenge is available here under Canvas. So you can click on that. It'll open this up to a link. It does say kind of erroneously that this document cannot be displayed within Canvas. Don't worry about it. You just need to click to download the study guide itself. You see that it drops down and it's accessed in your local computer. So if you're working already at this point in a local environment in Jupyter, you can just open that up directly from your local computer. Otherwise, you can go to Colab and upload this file to Google Colab. When you open up Colab directly, it opens up to the upload file. You can choose the file. Currently, I've got this saved under downloads, which somehow has disappeared. Yeah, okay. I don't know where my files went. Go back to that. We'll deal with that later, but it's under downloads. My study guide is going to be down here. I can open it in this method. Additionally, if that seemed like a lot of multiple steps, indeed it was, the study guide is also available under the GitHub repository where we've been accessing all of our notebooks. And you can see it that I've added it here to your Unit 1, Sprint 1, data wrangling and storytelling repository. You can open this up from GitHub. It's available to look through, and you just need to open it up with your Google Colab extension. So if you have any questions about that, feel free to send me a message or check in with me after class. Now, presenting and ready to go. All right. All right. Jason, you had a question about that 2-week break in March. I assume there's not a 2-week break in March, and that is some kind of error at the moment. The only break that is scheduled under Bloomtech scheduling is not till May. I have already reached out to the person who's in charge of that calendar. That is actually not me. And they are unfortunately out of office at the moment. So I'm glad you asked. That calendar needs to get a little bit revamped. So for the moment, please just ignore that calendar for content specific. Go over what you are using in Canvas at the moment. For the next 4 weeks, you're with me. I don't believe you have that 2-week break in March. I think there's some kind of error there at the moment. So please be patient with us as I have Dante, the person behind the calendar on that side, actually deal with that. So my apologies that I don't have a better answer for you at the moment. All right. When you refer to, when I mean, as far as the answers is yes, is where to find the errors in the code grade. When you're looking at the submission you've included as part of your code grade against auto grade, how to access and how to see and spot the errors that you've implemented. Cool. So, but there's a follow-up question here is like, are the actual answers displayed somewhere? Yeah, that brings me up to my next administrative point under Canvas. At the end or by the next day of every module project, you'll actually see a module project solution after every module. So you can see these are always unlocked the day after your module projects are due. This is in the event that you have thrown in the towel, you're not quite sure how to, you've asked questions, you're finding yourself stuck. This is a video of me going through all of the answers. So, you know, the condition is that you have to have not gotten tired of hearing my voice, but you can actually go through the full module project for the module projects individually. Now note, I don't have a solution video for the sprint challenge. That is unfortunately something that you have to navigate over the next few weeks, trying to make sure that you've got a perfect score with the resources that we have covered up until now and with the assistance from your coaches. Remember, the sprint challenge is available on Thursday at 5 p.m. You have unlimited submissions, you have unlimited attempts. So if you didn't get that perfect score by the end of Friday, do not fret. You can work on it over the weekend. Wouldn't recommend it. I'm still going to be here on Tuesday next week to help you out with continuing to make sure that you get a perfect score on those sprint challenges. You do have to make sure that you have made one attempt this Friday and the following Friday. Again, this is for us to make sure that you are engaged with the class, that you are engaged with the program. We need to make sure that you are actually submitting work. If you are one of those learners who is here but not really turning anything in, you can expect that 2 weeks from now, you might find that you're no longer a part of the program. So we want to make sure that you are engaged with the program. This is just an automatic check that we have to make sure that we are working with people who are engaged with the program. So attendance code, it's coming. Just gotta give me a break in the conversation. How many attempts do you get? As many as you want until February 6th. I am saying Jupyter Notebook. We'll talk about that more next week. For the most part, you're going to still be doing most of your work in Google Colab. What do we need to do that attempt at GCA? Don't worry about that yet. I don't want you thinking about the GCA until we've gotten past those first sprint challenges. Otherwise, you're going to find yourself overthinking this. This is something to work on next week. So hold your horses with the GCS. We'll get there next week. So So the sprint challenge is going to be a module project, much like what it's essentially the same thing you've been doing up until for the last few days. It's a module 1 project, and then there's a check for understanding. So there's a notebook you have to turn in and a multiple choice component. All right. I'm going to hold off on your I'll hold off on your questions for just a moment. Just make sure I've gotten all the other administrative things out of the way. Got the study guide. One more thing I want to show you. I throw a lot of video. You have the recording of this video, and I share any extra Loom videos, any kind of content that I want to make sure that you've seen an active guidance on how to approach on Slack. So most of those videos, obviously, I don't want you navigating through Slack to have to find where those contents might be. But the most important videos are always going to be present under the review section. So for yesterday's video, for example, our class recordings, you'll be able to find both the office hour recordings and the exploratory lecture, the guided lecture from yesterday, under class recordings. So please make sure to take advantage of those if you need to review any content from class. So that's where the recordings are, 5 out of 5. And now the attendance code is 7349. I think that's what I might have given you yesterday, but just in case, the code for today is 734. All right. Felipe, regarding your question, send me a message. We can look at this after lecture, see what happened with that specifically. And that's attendance code. And regarding Monday, yes. So Monday is a holiday. It's Martin Luther King holiday. So what's going to happen is that Friday, you'll get a recording of what you can expect the class to be, or what the guided lecture would be on Monday. So on Friday, you'll get a guided lecture on on hypothesis testing and confidence intervals. Essentially, it's just me talking to an empty camera. It gets a lot lonelier, and the jokes are just terrible because it's just speaking to a blank space. But the recording will be available to you as early as Friday, and you can essentially turn in your material, your module project, the multiple assessments, the sprint the check for understanding questions, and the pulse check over the following week. Remember, all of the module projects are due February 6th. So it's not, none of these projects are going to be due till the end of the unit itself. But you want to make sure to have taken a chance at completing it over those next few days. Of course, I don't expect you to do work on Monday. It is a holiday, so make sure to give yourself some time to recover, and just understand that that is available for you to turn in at your leisure. Of course, it's got to be before February 6th. So, and yes, to the whether we have a Zoom call, a guided lecture on Friday, no guided lecture on Friday. You will be working on your own on the sprint challenge throughout the entire day. So you have an entire day to catch up on all of the material that you might not have caught up with and to work on the sprint challenge. So it's a little bit of a longer module project, but it is intended to be a full challenge. So any other questions before we get into our lecture? These are great questions, great clarifications. Yeah, the code should be on the Zoom chat if you need access to it. It is 7349. Okay. So today, here's what we're going to be focusing on. We're going to be talking about how to access and how to work with data that comes in for the but we need to learn how to access data that is currently in one specific format and understand how to reshape. This kind of lines up with what we did yesterday, where we understood how to create new features and how to work some of the features into a structure that works well for us. So today we're going to be doing this with data frames or data sets from two potentially different sources. And we're going to be understanding how this is going to be combined together. Before I go into that, I want to just take a look at a quick real world example here. So before we get into the notebook, make sure I can see the whiteboard. There we are. You all see like a white board? Okay, cool. Let's go ahead. This is where you're going to start seeing my excellent art skills. Because here's what we're going to start off with. Let's talk a little bit about the DMB. Square. Why is this not working? Okay. Cool. All right. Now that works. So let's talk about the DMB. This is the DMB. It's a square box. Now, this is going to be a little bit more casual to start us off, but go ahead and turn off your mic. And I'm going to essentially ask you to call out a couple of things. So let's say you go to the DMB, you get in line. Say you're going in for your driver's license, whatever it is you may want. What is it that the DMB, what information, what data points does the DMB collect from you when you're trying to get a driver's license?
Your date of birth.
Date of birth, okay, great.
Citizenship, or proof of residency, rather.
Yeah, residency, okay.
Social security.
Okay, I heard a few things there. Date of birth. Address.
Name,
of course.
Social security.
Social security number, address, name, birth. What else? We missing anything?
Any endorsements you have, whether it be like vision detriment or CD4 or whatever that stuff is.
Cool. Did you pass your test? Probably.
Oh yeah.
Yeah, probably. That's what the license is essentially made to do.
Eye color.
Eye color.
And
Yeah.
weight and height.
Eye color. Weight and height. Cool.
Working donor status.
Owner status. Yes.
Gender.
Gender. Sometimes. Yeah. Yeah. I guess that's kind of, all right. Cool. That's a good list. So let's pretend that, like, understanding that nowadays, DMB takes all of this information, logs it in. It more likely than not, depending on the state that you live in, is working on keeping this information up on a cloud somewhere. Like there is a linked process to actually combine all of this information and actually store that data somewhere. But when they give you that driver's license, this is information they keep. Now, here's the thing. Let's assume this is one specific state, and this is a specific state that has multiple DMB sites throughout the state. Obviously, nowadays, we do think about how these DMBs are all interconnected. They all upload this information to the cloud. However, these are still two different sets or two different DMB stations that collect essentially the exact same information between one DMB station and another. So the question ends up being, when you want to connect this information, let me ask you, what is required for both of these DMB stations to be able to link the information together? Well, obviously, they need to make sure that they are collecting the same information from one DMB to the other. All of that information needs to be exactly the same in order for this DMB list to actually work, for this system, for this interconnected system to actually work. So say that DMB1 collects all of the data from a set number of customers. DMB2 presumably collects the same data from another set of customers. What you end up seeing happen is that this DMB, this list of data, gets stacked one on top of the other, right? This is how Excel works. This is how any kind of data list, anytime you've collected a list, this is how you build a list. It makes sense. This is where we come into the first part of the first general concept that we're talking about today. how to stack data one on top of the other, how to concatenate it, or how to join it together in a logical way. Both sets of data need to be the same. Follow-up question. Let's talk about, I don't know, the IRS. What information does the IRS collect?
Individual revenue.
Revenue, yeah.
Name, date of
Name,
birth, social
date of birth.
security.
Yeah, social security number. What else?
Any sort of like benefits or exceptions.
Yeah, all that.
Number of dependents.
That's all that. Yeah.
Address.
Have you paid your taxes, really?
Basically.
It's one of those things they're finding out. Cool. Let's go for one more. What happens if you're driving around with that new license and a police pulls you over and they have to give you a ticket? What information do they collect from you?
Driver's license number.
Driver's license,
Registration.
Insurance.
registration, right?
Insurance.
Insurance,
Name.
name,
License plate.
license plate, all that.
In some cases, weapons license.
Weapons license. Yeah. Okay. That's actually new. Yeah. Cool. Cool. So now here's the follow-up question. I enjoy looking at it on screen for this. Have you ever tried to renew your taxes, or sorry, have you ever tried to renew your driver's license after having not paid taxes for an extended period of time? I'd say don't answer that. You're being recorded. Have you ever tried to get a new license when you still have parking tickets or speeding tickets as part of your, on your record? Yeah, probably not. Or you can't do that. And the reason you can't do that is because the DMV and these different organizations are essentially constantly collecting information from each other. And the way they combine that information, the DMV doesn't necessarily reach out to the IRS and asks for all of the information. They're really just asking for very specific sets of information. How do they know to link you to whether it was the same you who didn't pay that, who was speeding on that highway that one time? Or how do they know to connect you to the person who didn't pay their taxes properly that one time? The trick is that they have to, as you probably already know, connect the information based off of a couple of different sets of relevant information for themselves. They connect your social security to your social security number. They connect your name to the name. They essentially merge all of the information together to make these determinations. This information gets collected and joined together in a method that the DMV can interpret and make essentially decisions based off of the information that they collect. So it's all based on taking data sets from different sources and connecting them along the same features. And this is what I want us to think about, or how I want us to think about the data that we're working with today. We are combining different data sets, and we're going to be combining those data sets based off of the features or the columns that are present in a specific data set. So let's go ahead and take a look at an example with some simple data from our notebook. Let me just quickly take a view of the questions we may have. Should we attempt the sprint challenge this Friday and weekend? Yes, you should definitely attempt it this Friday and weekend. Make sure to attempt it this Friday and submit something this Friday. You want to have submitted something by 5 p.m. on Friday. You don't need 100% until February 6th, but do make sure to submit it. Remember, AutoGrade gives you some amount of the answers when you submit it. So the sooner you submit, the better you have access to some amount of information, and you can continue essentially working and learning from there. Sprint challenge, no. So you get access to the sprint challenge on Thursday at 5 p.m. Pacific Standard Time. So Thursday, 5 p.m. Pacific Standard Time, that's when the sprint challenge opens. You'll hear an announcement from me as well as a reminder. Okay. Yeah. So that story of the DMB is also actually how I had my first exposure to data, because I was working as an economics reporter at the time and in Puerto Rico, and realized that the DMV had essentially stopped processing information. And a lot of that had to do with someone did an improper join or an improper merge of the data set. So all of the data that they were trying to collect, both from the police officers and the IRS, had been done improperly. And we're going to show you how that can happen with the data that we're working with. But what that resulted in is that I think back in 2007, the DMV lost access to all parking tickets that they had kept a record of because of an improper merge. So the real world consequences of not understanding of what you're doing when you're merging data together is actually very real, because you can very much lose a state, I'm guessing a little bit short of $1 million in revenue, or revenue in speeding tickets and things like that. So that was an interesting thing that happened once that happened back in my early days. I had no idea how the SQL system worked at the time, but we'll be able to touch on that to some extent. So we're going to be working with two specific functions today. We're going to be talking about the concat function. This is a pandas concat function that we'll be using to stack data one on top of the other. And we're going to be using the pandas merge function. So first and foremost, this first, this one's going to be a little bit, this is going to be a lot of, let me just make sure I've got everything set up where I need to be set up. And I will also set up a code thread to get started. Sorry, that should have happened automatically. All right. So this first line of code, we are importing the usual pandas and NumPy imports that we'll be using. This class, I'm simply taking the display function and making some changes. Don't really worry too much about what's happening here. All that this does is that it changes the display so that it actually throws data frames on a side, like side by side, rather than top and bottom. If that's something you'd like to do down the road, maybe compare one data frame against the other, you can always, you feel free to use this code for yourself. But I'm going to go ahead and start with a simple example. These are 3 data frames, essentially, that I've created. They're essentially very simple in structure, and we're going to be using and displaying one over the other. So when you run this cell, you'll see 2 data frames pop up. I clearly forgot to run my first cell. My apologies. And we're going to talk about the first 2 data sets. So here we have 2 data sets with the exact same information as their columns. One has an employee column and the other one has a group column. And inside these 2 columns, inside these 2 data sets, we have different names. Bob, Tanya, Jin, and Harlan are different from Jose and Paula. And we can see that there are a couple of different accounting groups. Now, when you want to, like, if you were interested in combining these 2 data sets, you would probably just want to combine these data sets by stacking them one on top of the other. And here is our first function. PD for pandas.concat. And it's going to pretty much be as simple as that for the most part. Within concat, you do have to pass your 2 data sets or your 2 data frames as a list. So this first parameter, this first argument, requires you to create a union of the data in an iterable format that essentially joins the 2 data sets together. So in order to pass 2 or to create a union of 2 different data sets, you would want to combine the 2 data sets as a list. So I have df0, that's this data set over here, and df1, that's my second data set. So when you concat those together, sorry that it sort of bounces. That's just because there's an image down here and I'm zoomed in. You see that both data sets have been stacked one on top of the other. So now both of the data frames are now 1. I'm going to go ahead and assign this concatenated or this unioned these two data sets into one. I'm going to assign this to a variable called df. Pretty straightforward. And I'll go ahead and let me go ahead and actually display this with my next data set. So that's df, and then my next data set is going to be df2. Cool. So now I have a different data set. This is the data set that I've just concatenated together. And here is df2. This is another data. This is the third data set that I had created above here. Now note, here I have two different columns. I have a hire date as opposed to a group date. And this hire date is essentially referring to the accounting, like the group of the, like in the firm. And then let's note, we have a couple of different individuals as part of this group. So Bob, we can assume that this is the same person. It's the same Tanya, this is Jen, and this is Harlan. Jose and Paula were probably, it seems like they don't have a hiring date listed at all. And Connie doesn't actually belong to any of the departments that are listed in this company. So far that's what we're looking at in this data set. What happens if we were to try to concatenate or to union these two specific data sets?
I assume an error.
Let's try out. So let's create a new cell for this just so that we can keep track. So PD concat. Again, it is a function. So we're creating arguments inside that function because I'm returning two different objects. I'm creating this as df and df2. Remember, these are the two data sets that I'm trying to stack one on top of the other. Is it an error? Oh, not quite, but it doesn't exactly do what we want it to do. So we've got all of the employees being double listed and then all of the values being listed as null values. That's because the information is not shared. These two columns are not exactly the same. The question that popped in, give me a second. So PD concat is a way to merge specifically two amounts of data frame. Technically, I seem to run into trouble whenever I try to merge more than one data frame. So if I were to add df1, it still works, but it starts to get clunky. So it looks like you can include as many data frames as you want, but generally speaking, and particularly for your assignment, try to keep it to one data set at a time. So great question. So concatenating it for this particular set doesn't quite make sense. It doesn't quite work. What would make sense, and I'll leave this up for reference and as an error, is to actually merge the two data sets. Because as we decided, we are trying to merge the same employees, but trying to create different categories or added categories for my group and hire date. I'm going to go ahead and show this as a thread on Slack. Follow along. That's my cat. And finally, let's actually merge those together. Now here's what's up. Concat means to, so you can actually do some merges. You can merge along specific axis. What I'm doing right now is I'm essentially just stacking or using concat to stack a value on top of each other. Concat is short for concatenate. So essentially it's to combine, whether along the row values or along the column axis. For our purposes, I want to teach you the merge method, the merge function, because the merge function actually does a lot more of what concatenating is doing, but with a lot more efficiency and ease. And with that, let me show you two methods. The pd.merge is also a function. And you can see this function opens up a bunch of documentation. That function is including left, right, how, string inner, on, left on, right on, left index true, or left index false by default, right index false by default. Do you want me to sort it? There's a lot of this. For the most part, we're only going to be working with these 6 arguments. So for the most part, and particularly for your assignment, aside from that initial step where you're going to be doing your concatenation once, you're going to be using mostly the merge. So I'm going to show you the pandas merge method, and then I'm going to show you a different way to do this just in case. Our original data sets were DF and DF2. DF is going to be the value that I'm including on the left side. So think of this as you see it on the screen, DF is going to be the values that are going to be on the left, and DF2 will be the values that are going to be included on the right. Now, how refers to how do I want to join the values together? I'll take a moment of that in just a moment, but I want to focus on the on parameter. The on parameter specifies which column you want to join the values on. So let me ask you this. When we're looking at these two data sets, what's the column that they have in common?
Employee.
Employee, yeah. Very straightforward. So we can specify that for employee, and we can run it. And let's look at our results. We actually have a nice little organized data set that includes all the values that the two data sets have in common. So Bob, Tanya, Jen, and Harlan are both values that are in both data sets. So those two values get included and all of their information is completed. Pretty cool, right? Because now we have a completely new data set that we can do work with. But hey, Julian, what happened to Connie and what happened to Jose and Paula? Frankly, the same thing that happened to all of those parking tickets in Puerto Rico all those years ago. This is where how you decide to merge. Oh my gosh, this is the best time that punchline has ever worked. Sorry, I need to give myself a round of applause for that because I haven't actually delivered that punchline in a while. Okay, enough of the bad jokes. So this is where understanding how to join your values comes in handy. By default, the documentation for the pandas merge function is set to inner. And just like any Venn diagram, as we can see here below, an inner join specifies that it's only going to combine the values that it sees under the employee column that are present in both data sets. Let me say that again. An inner join, the default status for both SQL and Python, is to join the values where both values are present under the column you choose to join your values. So DF and DF2 only have Bob, Tanya, Jim, and Harlan present. So this becomes an inner join. And all of the other values get remained. If I wanted to include all of the values that are present on the left data set, in other words, all the 6 folks that are here, Bob, Tanya, Jen, Harlan, Jose, and Paula, I would want to choose a left join because the values that are not present, in other words, Connie, would not be included. A right join does the opposite. The values that are in my DF2 would be included, and then Jose and Paula would be excluded, and I'll show you in just a moment how that works. And then I'll show you with an actual example how those values work with an outer join. All right, so quick reason of why I like to favor merge over concat for merging values along the column axis. Pandas merge is extremely smart. Pandas merge will look at both data sets and the columns on both data sets and try to identify what of those columns both data frames have in common. So I don't actually need to specify, for the most part, what column I need to specify, what column I want to merge under. Because pandas merge knows that in DF and in DF2, there's a column called employee that they both have in common. So an inner merge is going to be the default status along the column that the values are recognized, like it recognizes that the two data frames have in common. What happens if I want to specify a left join? Well, just like I said, a left join brings in Jose and Paula. It doesn't keep Connie. And as a matter of fact, the higher date stays as a not a number because that value isn't present in DF1 or in DF prime. So DF prime, if you can see, I've got Jose and Paula, I have them in accounting and engineering, but I don't actually have a higher date for them. And that's why that's a null value. Zoom in. If I change this over to right, Juan and Paula get excluded, but Connie gets included and she has no department in this case. So they are essentially listed as a not a null value. Yes, so the question that popped up that I just saw is like when I'm specifying how to join, I do not need to include the on if I know from the get-go that the employee parameter is present in both data sets. For example, if I wanted to try to join on group, this will throw an error because the key error is not present inside one of my data sets. So there's no way for me to join along that column. Now, what happens with the outer join? Outer join is really fun because the outer join is just going to include everything. And that outer join will include all of my prospective employees. As we discussed, we explained that we join that along the employee status. I'll go ahead and include that in. And then all of the values where those values are not present in one group or the other will be assigned as not a number. All right, take a look here. Concat means, yes, I think that was, I think we specified that earlier. When you're specifying how to join, you do not need, not with the pandas merge function. Tricky thing, and that's a good question to start to consider right now. In pandas merge, it's an intuitive function. It will recognize whether an employee has whether there's a comment, whether there's a column in common in both data frames. In SQL, that's not the case. In SQL, most SQL languages require. Let me put a pin in that because DB Postgres SQL now includes a little bit more intuitiveness with their joins. And it's been a while since I've worked with SQL, but so that's just one of those things that that they essentially that they might have cleaned up from in the last few days. So why is higher date afloat in the merge data set? All right, actually, that's a great question. Why is higher date afloat in the merge data frame? Someone come off the camera and tell me and answer that question for me.
Is it because the not a number in the column, so it doesn't, it's a mixed set now, so there isn't just integers, so
There
it
you
converts
go.
everything to floats.
Exactly. So I want us to think about, remember that NumPy treats not a numbers as float values. That would make outer join the safest move, but yeah, you would end up having a lot of null values. Now, here's the thing. Outer joins aren't necessarily the safest move in the sense that you'll include all of the information you want, but sometimes that's not what you're looking for. This is where you as a data engineer need to be very purposeful as to what you're choosing to join or what values you're choosing to link together. Outer joins will bring in everything. And sometimes that's a little bit more information than you actively need. Most of the time, and if you're a strong, or if you are, how should I put this? My recommendation for data engineers when working with SQL is that you are, for the most part, using either left joins to specify what information it is that you are purposefully trying to attain, or inner join to specify that you're only looking for information where both values are in common. Most of the time, you're going to be working with left or inner joins. If you're working with right joins, there's a certain extent where you can address that that a lot of whether the difference between left and right joins is how you organize your data set. So it's more about like, oh, I want to do it in this order. So I'm going to bring in DF on my left first and DF2 afterwards. If you were to start doing this DF2, for example, as a left join, it's really more of a matter of like, it's a matter of organization. So as you can see, this still brings the left join, but if I wanted to bring in what I had originally, I could also just use a right. So a lot of it has to do with how you organize your data set first and how you choose to display and keep your data set organized. Let's keep that there. And let's add one of these with a left join so you can see the difference in future notebooks. So in the parking ticket example, they needed to do the outer. In that case, the problem was that they joined to, this is speculation because this was years ago. I did not know how to use SQL. I wasn't versed in data engineering at the time. My suspicion is that they joined information from, they started using a new database and they didn't transfer all of the queries in the same format. So I think they had to redo some of the queries. So when they created their database, they might have joined in information from the IRS, but didn't properly create a space or probably just did a left join where they didn't consider the column from the parking tickets. I'm not entirely sure. Again, this was years ago and I was not well versed at the time. So this is just me when I look back, when I reread that broken newspaper article, it's clear it was written by a not very data literate journalist, someone who didn't understand SQL. I was 19 at the time, leave me alone. So if you have more than one shared column between two data sets, are all shared columns merged? I'm going to put a pin on that question. So we're going to come back to that. All right, so this is a simple example. What happens when we need to deal with millions and millions of rows of data? This is essentially where you would want to consider when you're working as a data engineer, when you're working in SQL, most of the time, you're going to want to make sure that you have some form of data map or, I'm blanking out on the word for it. Anyone who's done data engineering in the past, can you remind me of the name of this type of diagram? Because I just blanked out on that. Feel free to share it on the DS36 channel because I don't remember that off the top of my head. But what you want to do is note what columns do all of the different data sets have in common. And this is how you're going to begin to link the values from one thing to the other. Having this data set or having these types of maps will help you organize and keep your values, it will help keep your values together. And most professional data engineering processes have these types of data maps. Data maps is the wrong term for it. I'm going to get back to you with the answer for what this thing is called. So my apologies that I don't have that off the top of my head. Because when you're working with large tables, when you're working with large data sets, sometimes you're going to be working with really big sets of data, and that can be fairly overwhelming. So let's start off. Let me take a look at the time. Actually, yeah, let's go ahead and take our break a little bit earlier than we've been doing over the last few moments, but it's not like a nice round number. So let's come back at the hour. It is currently 50. It's 10 before the hour. Let's come back at the hour on the spot. By that time, I'll have the answer for you as to what I'm looking for here. See you in a bit. Wonderful set of words. Thank you for the reminder, Crystal. All right, so yes, this is, thanks to Crystal, this is an entity relationship diagram. Sometimes referred to as a document, but essentially it's just helps you link these values together. All right, so while you're all coming back, here's the good news. This is half of all of the functions we're going to be working with today. Towards the latter half of this hour, we're actually going to be looking at some group bys and a little bit of a function for tidy data, but for the most part, this is all you're going to need to do to begin to join data sets in Python. So let's take a quick look at this data set, and I'm going to double check my notes to make sure that I'm consistent because we are joining 4 large data sets. So one is order products prior. See if you can keep track of this. So order products prior has 4 columns: order ID, product ID, add to cart order and reorder. Order products train, if you run these 2 cells, has the same 4 columns. So we can go ahead and presume, and I'm going to ask you to presume away because I'm telling you to, that these are 2 different data sets that have been split apart and will be unioning together. Essentially, we're going to be stacking one data set on top of the other. So think of this as the 2 DMVs example. We have another data set called orders, starting to get confusing, where we have multiple different data sets that we want to consider. So we have order ID, user ID, and evaluation set. We can already begin to see, because we have eyes, that order ID and order ID are columns that these 2 data sets have in common. Keep track of that. And finally, we have the products data set. The products data set includes product ID, product name, aisle ID, and department ID. And just by seeing these 2 values, we can see that we have product ID and product name potentially, but those aren't present here. However, products has a product ID with our 2 data sets from up above. So we're going to quite carefully make sure to join all 4 data sets together into one mega data set. So let's start off by using our pandas concat method to join our prior and train data sets. And that can be done with pd.concat. And remember, you're returning a list value for order products prior and order products train. I'm going to go ahead and assign this to a variable that I'm going to call order products. And we'll be able to display this as well in our next line of code. This is the last line of code in our cell. And note, we have a data set that has 50,000 rows of both values having been stacked one on top of the other. So 25,000, 25 plus 25 is going to be 50,000 in this scenario. Let me scroll back down. And here is our first joined or unioned table, all stacked one on top of the other. So now that we're down to 3 data sets, let's talk a little bit about how we are going to be joining these tables together. So the orders data frame, we're only going to be using a number of columns from each data set. Specifically, this orders products data set, rather than using all 4, I think I'm only going to be limited to using only 1, like maybe 3 of these at this point. I'm not sure if we're going to be focusing on the reordering column at this point. So, but as we're looking at this table, as we're trying to think about how to recreate or create a data frame that works for us, we're going to be very careful to note that we want to organize this in a very specific method. And we're going to be thinking about what part of the data set do we want to prioritize? Are we interested in looking at the order names? Are we looking at the product names? Are we looking at when an order was placed? All of this informs the order or the process in which we join these data frames together. So this is very much a matter of how we choose to prioritize this data set. If, for example, my priority was the police of Puerto Rico's ticketing agency, I would have had to make sure that the ticket, the amount of the tickets and who those tickets were assigned to needed to be a priority in how those tables were joined towards the DMV in order to collect. The funny story is that the only way they could collect any of that missing revenue was people who would show up to the DMV with the physical ticket in hand. And it was like, I just have to feel, I feel terrible for those folks, because what I was able to get the report out. I was like, hey, in my, journalistic mind, I was like, don't bring your physical tickets to the DMV. They don't have the info on it. Just show up. just show up because they have to like get this somehow. Just don't show up with your tickets in hand because otherwise they'll get you. Anyway, random merge, random aside. So let's actually go ahead and combine these tickets, these data frames together. And from one of these data sets, we're only going to eventually focus on a couple of these columns. How, though, do we want to specify, or say we're working with more columns than we can just look, that like we could see that order ID was the column that both data frames have in common. But what if we don't have the power to do that? Well, one quick trick is you can use the properties of Python to recognize one of these values. So set is a way to create a set object. And if we remember from our first day, a set doesn't allow for duplicated values. So when you specify your order products, that's the table we've just unioned together, we can create a value from the columns. And those columns are all listed as a set. Those are the 4 columns that I have from that data frame. And I can also combine a set of the orders column names. And when you combine these 2 values as a conditional value, what you get is it'll only find the columns that both values have in common. So if you're ever wondering how to access 2 different, if you're trying to find a list of values and trying to find what 2 lists, what those values have in common, what those 2 lists have in common with each other, this is one easy and quick trick, using set to assign both values. So now that we're able to recognize that we're going to be joining along the order ID column, let's go ahead and merge it together. So pandas merge is going to be joined on the left side with let's focus on orders first. Then let's do order products. And this, I'm just going to be very specific. So I'm going to specify, even though it's the default, that I'm joining along the inner with an inner join, because I just want the values where both of these are in common. And I'm going to be joining along order ID. This is just to be as clear as I possibly can. So now I'm prioritizing that along the order ID of every single order, we have 357 rows where both values are present in the orders and orders products. I'm going to go ahead and assign this to a object I'm just going to call orders and products. All right. I'm going to make one more quick aside. This method, pandas merge, and combining the left and the right, is potentially going to be deprecated in maybe 2 years. The method that is essentially more up to date, or the practice that is now currently more Pythonic in format, is this method. Orders.merge, order products. Now, this displays exactly the same information. It defaults to inner. It will ask you to specify if you don't want to specify the column name. And we'll talk about left on and right on in just a moment. But you'll notice that this actually works at the moment exactly the same. But about a year from now, this is a method that's going to be the preferable method to use. This is the updated style for merging. For your assignment, both methods work and both methods return the same result. So it's up to you which path you choose to use when you are updating or working with pandas merge in this scenario. So that's just one thing to go forward. Let me make sure that we are all coming along together. This can get tricky. Pythonic refers to the most effective way to create code that is both readable and effective. You're looking for clean code, and you're looking for code that essentially does that follows the principles of a Pythonic simple code. One of the import Easter eggs that exists in Python's underlying code is the Zen of Python that essentially asks you to follow a specific philosophy. Now, at this stage, we're not there yet, but it's just one of those things that you can essentially work towards. How do you assign a variable to it? You do the same thing you just did. So this is an orders merge. Because variables aren't saved, you would just do exactly the same thing that you would do above. So order products works exactly the same. Okay, so we have our orders and products. These are merged together. This happens automatically. I'm going to skip the import this. All right, so let's find the next value. We still have our products table. We remember our products table has these columns. Let me go ahead and make sure I can spell columns properly. May need to zoom in here. And we were going to join along the product ID. Now, because orders and products is a new table that we've just joined together, let me actually make sure I'm spelling this properly. It's orders and products, and the set for products columns. We're going to be joining this along product ID. Why did I specify inner on the orders products if it does that by default? Just to keep my code clean and concise, and just to make sure that we are aware of what's happening behind the scenes. It happens by default, but I just want to make sure that I'm being super specific. Because in just a moment, we're going to answer your earlier question of what happens if you have two columns in the same data frame. All right, so let's merge this. I'm going to use the new method or the updated method for this, orders and products dot merge. I'm going to merge this along products. And so note that the value you put inside the dot merge is going to end up being your right data frame, or the data frame that you'll have on the right side. And of course, because merge is so smart, it's actually going to understand that because there's only one column that they have in common, it's going to default to the product ID value here. So now we have our full data set. And you see that this is a massive data set that includes all of the information from all four tables joined along the product ID and the order ID from earlier. So now we have all of the information that is relevant to us because we are only looking for values where the order ID or the orders are present in our current products. So this was the priority, or this is the priority that we are aiming to direct towards. It is a much smaller data frame, down from 50,000 rows to something that we are prioritizing for our own particular check. So I'm going to go ahead and assign this to a variable called final. I'm using final underscore in order as a shorthand to signify that, hey, I want to do some additional work to this data set. I'm not actually going to be using all of these columns really at the same time. So for example, I'm not really going to focus on the department ID. I don't really want to focus on the aisle ID. So these are a lot of columns that I might end up dropping. So I'm just going to run this as a quick shorthand and do just some little bit of nitpicky cleaning up. And what I'd like to do is simply specify that as part of my final data set, I would like to include just a few specific columns. And of those columns, what I'd like to work with is the user ID. This is not something you have. This is just something that I'm kind of taking from previous notes. and the prioritizing the values that I want to work with. So this is order number. I do want to look at the day of the week that a value was created. Order, hour of day. Let's not work with, yeah, let's just keep it just in case. Add to cart order. Kind of up short here. Cart order. Finally, I have product ID. And finally, product name. Let's see if that works. Cool. So note that what I've done is I've taken the data set and I've specified and created this in a data set that I would like to find a little bit more manageable with my product name at the far right and some of the more relevant information towards the left. And this is the value that I'm going to assign as my final value. Let's go ahead and share this on Slack, so you have access to it. Remember, if you need to refresh the page, yes, so it matters which order of the table we merge together. Remember that you are going to specify based on the merge function, which is going to be your left. This is going to be your table on the left. You look at the difference between final underscore and my final table. You'll see the biggest difference. It started with order ID, user ID, eval set. When I've created this new data set, this lines up with orders and products being the first table that gets joined together, and the products table being the last three columns on the right side. When you combine that, note that while I'm doing is I'm taking a different set of columns, reorganizing them, and focusing them in the order that I would like them displayed, and saving this as my final data set. And once I've done that, we can now start to think, if we were on the business side of things, how we would like to process and what kind of questions we might want to ask about our specific products. And this is where the functions that we've learned over the last couple of days will come back to help us do some EDA from our data set. Before I go too far down, I do want to highlight one quick thing. I did a step-by-step process where I included all of the columns from the product table. But remember that this merge function works the same way as a data set. And it's just a matter of the possibility of creating a data frame can still be linked as part of this object. So I just want you to take a visual look at how this works. So these are the last three columns from the products table. I have products name, aisle ID, and department ID. But if I only wanted to join along the table, along the values, product ID and product name, I can do that within the, while I'm actually merging the tables together. So if I run that table, you'll see that I still keep product name. Product ID was the column that I merged on. And I don't actually need to include all of the columns from one specific data frame or another. This is relevant to you only if you're trying to minimize how much processing power you're putting your database through. Rather than having to merge the entire data frame, you can always select specific columns from an existing table. So with that nitpicky question, let's go ahead and answer some questions about the data set. And I promise the question is, what happens when you're trying to deal with two columns will be addressed in just a moment. I promise. So feel free to shout it out. I'm looking at the user IDs in my number of columns. How can I figure out the number of unique users in this data set?
Is it the n unique?
Yeah, that's right. User ID and unique will tell me that out, and unique will tell me that out of 185 rows, only 173 are actually unique values. Here's a trickier question. How do I find out how many users ordered only once versus more than one time? Let's look at our data set. So we have our users, and we can assume that every user in this data set has ordered, like we can assume that every row in this data set stands for a very specific order, because we have the order ID, we have when that order was placed or what number of that order was placed, the day of the week, what time in military time. Let's disregard this for right now, the product ID and the product name that was ordered. So now that we understand that we have 173 unique users, let's take this one step at a time. How do we find out how many of these if 173 users are unique, how many of these users probably have their name more than once? What tool could we use for this?
Is it value counts?
Use value counts. Yeah. Value counts allows us to return all 173 users, and we can specify how many of them ordered once. We can assume that all of these values at the very end are the folks who just ordered once, and we can assume the folks towards the top are the folks who ordered more than once. For those of you who worked through the D-type question yesterday in office hours, what's a technique we can use to find out how many of these folks ordered once versus more than once? Those of you who like method chaining, always attach value counts again. Value counts attached one more time will tell you of these users, 163 are only present having ordered once. 9 ordered twice in that data set, and 4 folks ordered, and only 1 person ordered 4 items. Scramble to look over notes. That's right. It's okay. Method chaining can be fun when used properly. At what time were most orders placed? What column am I looking at? At what time were most orders placed?
Order hour of day.
Hour of day. What's the tricky question we can use, and what's the favorite function we can use for this? Frankly, value counts is going to do so much good for you. Order hour of day. That's not the name of the column. What's the name of the column? Order hour of day. This is a messy data frame that would require quite a bit of cleaning down the road. There we go. We have most orders having been placed online through Instacart at 3 p.m. military time, by which we mean 20. What's the next question? What day of the week? It's the same process. Note how I'm doing pretty much everything one step after the other. Day of week returns 0 as my day of week. From additional research, this is just referring to Monday. Let me share this for you because I feel like I went a little bit too fast on y'all here. So that's the final data set. That's that final line of code. And that's the unique value. Sorry. What other questions do we have? What day of the week? These orders were placed on, I believe this is an order placed on Sunday. I don't remember if 0 stands for Monday or Sunday. Before we go a little bit further, because if you've been looking at your syllabus, you'll notice that tomorrow we actually go into visualizations in Matplotlib. But before I teach you the hard way to do visualizations, because we're going to be working in Matplotlib and Seymour, I want to show you a quick trick that you can use as part of your EDA. Because part of your EDA is going to be understanding what's happening with your visualizations. So one of the tools that exists in Python is to use the dot plot method. This is a pandas method that was integrated into Python's base method for, I think in 3.3. It was either 3.3 or 3.6. I don't remember which one of those it wants. But the plot method is a function that you can chain together to all of your values. And by default, it creates a time series or a line graph. But as part of .plot, you can actually specify a couple of specific within its kind parameter, the kind of visualization that you want to use. In this case, I want to create a bar plot that specifies what day of the week had the most orders. In this case, it was day 0. I believe in this case, day 0 is either Sunday or Monday. Julian, I'd like to actually have this in order of day of the week because I don't want it to be in like Monday goes before Tuesday and Tuesday before Wednesday. So it would obviously make more sense. For that, excuse me, let's go ahead and use a technique called sort index to organize our values in a logical way. So now we have, this makes sense that it was Monday. So 0 for Monday orders and Friday and Saturday for all spiking orders down the road. So quick and dirty way to create a visualization from the get-go. All right. Follow-up question, what was the most commonly ordered product? For that, we'll need to take a look at another column, perhaps from this data set. Product name. What are we going to use? Same thing, value counts. Looks like it looks like this data set is very friendly towards bananas. And how many of these products were ordered more than once? Well, let's use the same method to determine these values, one over the other. Products on top of others, value counts. And now we have whatever product was listed here. It looks like only 5 products specifically were listed, were only ordered once. And everything beyond that was ordered more than once. All right, I think I saw that this next question pop up where, hey, what if we want to actually integrate this information into a data set? Well, we can create a subset of the data set. In this case, if we're looking for products that were ordered multiple times, and we can view the names of those products by linking it together. The method we would use for this purpose is this method of like what we did just now. So we've got value counts, we have our orders. We can actually submit this or use this as a mask for additional values. I'm going to demonstrate this by assigning this to a variable called order counts. Note that all I'm doing is using this line of code. And I'm going to specify order counts, all the values that were ordered more than once. You see that it returns a Boolean list. And what can we do with Boolean masks? We can assign them to itself, order counts, create a mask, and we now have a limited list of only items that were ordered once. I'm going to go ahead and save this to a value called multiple orders just for assignment. We'll go ahead and show this on Slack. All right, I'm seeing some, did I misunderstand military time? I am ashamed of myself. Oh, no, correction. So no, I did not get it wrong. So 15 is 3 p.m. So note that I'm looking at the index. So if you look at the order of day, good catch. But this is all of the times that are listed inside the data set itself. So final refers to what time it was ordered. So this is 2 o'clock, 4 p.m., et cetera, et cetera. But when you include that as a value count, This is how many orders happened at 3 p.m., how many orders happened at 8 a.m., how many orders at 5 p.m. So good keeping an eye out, Emilio. And I appreciate keeping an eye out for that. So yeah, good catch. Let's see, how many times did people order one thing? Well, I can use the same principle that I just used up above here to determine how many times things were ordered only once. So if I've got my order counts, and rather than specifying all the values that were only ordered once, I can highlight order counts once. Again, same thing, it's a Boolean value. So I would specify this value as a mask to my order counts. And now I have a list of all of the values, all of the objects that were only ordered once. And what did they order when they ordered one thing? What did they order when they ordered one thing? That question's answered. Oh, how many times did they? Okay, sorry, I got my order mixed up here. So how many times did people order one thing? Let's take a look at that. There's a couple of ways we can actually take a look at this. We can create this into a list and actually just count the length of those values. So how many times did people order one things? 157 times. This is information we had previously. And then if we wanted to find out what they ordered when they ordered one thing, I would take that same value, keep it as part of my masked value. Order counts. It's part of my mask. That's the answers are now correctly placed where they're supposed to be. All right. So this answers all of the questions of using the chain values. Yes. So Felipe asks if we're using the chain value counts, can we assign each row to a different data set? Absolutely. So say you want this value to be your data set. One trick you could use is called PD data frame. Let me do this in a separate line. So I'm going to take this information and use a function that exists in pandas for PD data frame. Okay, let's try that again. PD data frame. This might not work actually now that I think about it. Oh yeah, there you go. You can create a data frame that works in this method. So this has your objects as a list, like kind of created in the method of a series. And here's a trick we'll learn about next week. You'll use the transpose method, which is a .t, to rearrange the objects in however you want to interpret this. So Felipe, you're getting ahead of myself in a little bit because we're going to be talking about data as we're talking about tidy versus untidy data. Using the underscores is a better, this is just syntax. So using the underscores is a better way to organize all the data rather than not hitting the space button. It's just a matter of syntax. Yours starts with raisins, mine starts with raisins. So we're good on that. So if you have raisins, I have raisins. If you didn't get raisins, don't worry about it. It just might mean that the merge happened in a different order at one point or another. Nothing to worry about too much at this point. But yeah, this is looking at things a little bit further and more advanced down the road. All right. So that is concat and merge and all of the things that you can do with those two tools. Let's talk about the third method or the third function that we want to be learning. And this one's tricky. This is GroupBY. And GroupBY is going to be helpful to learn now because then you'll be an expert at understanding GroupBY values in SQL down the road. Let me pull up. Let's pull up the whiteboard again. Let's say that you are someone who's playing marbles. Where did you go? Where are you? Whiteboard, whiteboard. Ah, hello, you're still there. Ooh, messy. On my screen, it's so messy. All right, I'm going to take a screenshot of this in case anyone's interested in keeping that my great drawings. And let's go ahead and create a bunch of marbles or a bunch of different shapes and symbols. Let's create a bunch of arrows. All right. Cool. So let me ask, how many of you played marbles as a kid? Or were horrifically traumatized by it in the last series of Squid Game? Right. So generally speaking, when you're working with marbles or when you're working with cards, whatever you're choosing to do, you are looking at individual values, and what you would want to do is organize them. Let's pretend these are all different marbles. You would essentially never keep your marbles organized like this, or cards. You would want to keep them in separate groups. So you would take all of these individual grouped values and put them somewhere else. I don't think I have the ability to move stuff. Let's see, can I move stuff? Yes, I can. So you would want to group your values in a very specific method. So this is me essentially moving things one place to the other. This is really all that GroupBY does. GroupBY takes all of the values that you're looking to categorize them and puts them in separate groups. And this is the first step of a GroupBY split, apply, combine method. Let me say that term again. The split, apply, combine. Because your data sets are typically going to be, as you saw them earlier, all bunched up together and grouped in kind of a disorganized mess, depending on the column and depending on the value that you're trying to aggregate to. But when you group a value, you've essentially organized all of your values into different groups. And that is step one of the split, apply, combine. I've split my values up. The apply means that I am going to next apply a mathematical component. That mathematical component, for our sake, is I'm simply going to count my values. There are 4 hearts. There's 4, 5, 6, 7, 8, 9, 10 arrows, and there's a bunch of X's. That is me applying a mathematical component. And finally, in order to display the information, I will bring all of these values back to their combined data frame. This method, I'm going to share screen and go back to sharing the screen properly. Okay, we're back on the notebook. Let's see if I've got all right, so this method is essentially the 3-step process that any GroupBY method takes into consideration. It takes a data frame, it splits it up into the groups that you chose to specify. It applies some kind of mathematical component. In this case, 1 plus 3 is going to be equal to 4, 2 plus 2, and 5 is going to be equal to 9. And 3 plus 4 is going to be equal to 7. And it's going to take those groups and combine them into an easy to read format. You can find this visualization by just doing a split, by doing a Google for split, apply, combine. So with GroupBY, what we're doing is essentially what value counts does for us. So for this next task, we're going to be using the Disney Marathon data set one more time. And I'm going to demonstrate how, when you try to group your values, let's go ahead and use the group method and use value counts. What value counts does is essentially a split, apply, combine, where it splits all of the different instances of M30 and 34. It counts how many of those values. It applies a count, it counts those values, and then it combines it into an easy to read aggregated method or an aggregated visualization. So what we're going to be doing next is we're going to be applying our own different mathematical components to different groupings. And the syntax for that can be a little bit tricky. I'm going to walk us through this step by step as best I can, because this can be somewhat confusing at first. So let's start off by taking a look at these first questions. If we're looking to find the average times for male and female runners in the Disney data frame, we would have to understand that we have, in this data frame specifically, the limited to genders. We are looking at finding what is the average time. So if we were to try to find the average time for all runners, the way we would do it is we would call the minutes of how long a specific, like the specific entire data frame, like actually ran through. And we would then aggregate this mathematical component of dot mean. So here I am applying find the average for all the minutes in the entire data set. And this returns an average of 363.72 minutes. That part's pretty straightforward. But let's notice the syntax. What I am doing is I am applying the dot mean to the number of minutes. So I'm looking for the average number of minutes to this series. That's that syntax. The added component that we're using here is that we're going to be using the dot GroupBY function. When you open up dot GroupBY, you'll see that it asks you under what component, what axis. To be fair, I've never really done anything but use this one parameter, so don't worry too much about the rest. So dot GroupBY, and remember, I'm looking to find the average time for male and female runners. So in this case, I need to look at the gender column, because what I want to do is I want to split the genders into males and females. I'm going to run this without having done anything, just so that you can see what happens. It doesn't display anything. It actually tells you this is an object. This is a data frame GroupBY object. I can't show you anything because I'm not entirely sure how you want to aggregate these values specifically. However, because it's a data frame object, the same principle that I applied when I was trying to find the mean for all runners still applies. So I would find the number of minutes followed by how many in average minutes. So note, this is two separate components. This is the number of minutes applied to a data frame object that's just been grouped under the specific GroupBY method. So when I combine those minutes, I'm at this stage of the apply method. And when I run it, I will get both genders split up into two different categories with their averages for each individual gender in this case. Take a moment to see if you have any questions. Okay, so why is gender in parentheses and minutes in brackets? All right, let's take a look for just a moment. That's that's usually the question that comes up, so that's fine. Let's take this back from the beginning. All right, Disney is a data frame, right? That part we know. When you create a bracket for minutes, I create a series. That part's fairly straightforward. This is a column value. When I apply the dot mean, what I'm doing is I'm taking all of the series value here and calculating the average for all of those numbers. So that's the mean for all numbers. Now, let's take a look. I'm going to go ahead and erase this for just a moment. Actually, let me go ahead and just keep this aside for just a moment. Hashtag. When you do the GroupBY, you're creating a function. Because it's a function, that function comes with round parentheses where you need to specify by what column. That's the parameter I need to specify what value I'm grouping by. So by gender. When I run this, what I've created is a data frame object. That data frame object can still be, you can still apply different functions or different applications from the series values. So why is minutes in a bracket? That's because I'm calling the minutes column the same way I would call it for Disney brackets minutes. So I've just done exactly the same thing I've done above. And as you can see, when I run this gender minutes without the aggregated method, it actually returns a series object. That's the same thing that this object is up here. Both of those objects are series. They've just been grouped by or aggregated along the gender. So when I apply the mean, what it returns is the aggregated mean for both individual genders. Tricky. This will take you some time getting used to. I'm going to recommend that you practice as much as you can. So for example, let's practice with average age, because the syntax, and Ben, if your question is because gender is being used as a function, is yes, because it's being used as an argument of the function. So that is correct. GroupBY is the function, gender is the value you were associating as a series. Yes. Correct. So you guys, yes. So gender is the function and gender is the parameter. That's right, Philip. Thank you. Yeah. So let's try this again. Disney, group by. What is the column that I need to group by in this case? Let me go ahead and pull them up. Disney.columns. What should go inside the group by? Someone call it out.
Gender still, right?
Well, the question's
Is it
asking
still
for.
asking?
Yeah, actually, you're absolutely right. Gender. So what's the column that's going to go in the square brackets?
Age.
Age. That's correct. And finally, we're looking for the average. We're looking for the mean. Let's take a look. This one's a little bit trickier because we haven't looked at this aggregator yet. But for each group, what was the fastest time recorded? So Disney. What goes in here?
Gender again.
Group.
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 That's right. And what was the fastest time recorded? We have net time, minutes. What do you want to
Minutes.
use? You want to use minutes?
Yeah.
Cool. And finally, this
Max.
one's tricky, max. Because a max will return what was the fastest, well, tricky.
Yeah.
Yeah, max returns the highest value. So this is technically the slowest runner in every individual group. So in this case, you would actually want the minimum or the smallest number of minutes in each category. That is something to commend. That is wild. Oof, okay. I'm never doing a marathon. Just never gonna happen. Okay, so the question, I've got a couple of questions. Austin, yeah, we'll actually have some time at the end of this class. So yeah, hang on. How come sometimes you can specify the column after the and then the function and method, but in this case you have to put the column in after the function. Okay, yeah, let's take a look at that question. Can you do group by age minutes? So unfortunately, the question is, can you do this? And the answer is not quite, because what you're working with is creating a new column. So as you can see, it already, like in this case, it's already telling you that you've already selected a column minutes. If what you're trying to do is group by along different columns, so you can try doing minutes and age. So you're trying to group by minutes and age. And if you want to find the average for both, you can do that. So this is something you can absolutely do if you wanted to create multiple, if you wanted to get the average for multiple categories. So to answer Felipe's question, if you wanted to get the average for multiple columns at the same time, we just include that as a data frame. When it comes to applying time and coding, is it easier to keep in minutes? And if you use hours, is it easier to use 24-hour clock or military clock? Whew. That is where daytime becomes its own warm-up activity. We have a warm-up activity for daytime if you're so interested. I didn't include it at any part of your assignment because daytime values are tricky to use in Python pandas. However, that warm-up is still important for you to actually notice and analyze because it will come down in handy for the most part. Generally speaking, if you can use minutes, you don't have to convert hours. You don't have to multiply hours into like 60 minutes. So wherever possible, if you're the person collecting the data, just try to do it in one format that doesn't require you to do having to convert hours to minutes because date times are tricky. All right, so how come sometimes you specify the column after the data frame and then the function? But in this case, you have to do the column before or after the function. This is where the syntax comes in handy. Understanding the syntax is very important. So with any function, there are functions that belong to data frames. So for example, .head applies to the data frame, to a data frame object. However, some objects apply to series objects. I'm going to go ahead and save this as a value so that we can see what parameters pop up when you run it. So a series has a completely different set of potential objects you can use most of the time. So if you wanted to find is null values in a series, you essentially return those values to the series itself. So to answer your question in short, is that it all depends on whether you want to apply a function to a full data frame. Like for example, isNull applies the isNull function to the entire data frame, or if you want to apply it to just one column at a time. So that's the biggest difference. In this case, because we are applying the GroupBY value, let me go ahead and keep this up. I'm going to leave this here. I'm going to keep it as a separate line of code. Then that goes there. So in this case, okay. Because we're only looking for the average time in the number of minutes, I am applying this GroupBY function. Like what I'm doing is grouping to the data frame and then calculating those grouped values as they exist in that data frame to the number of minutes. So to the question, Disney age is null. You're missing the round parentheses at the end of is null. That will apply the is null function to the series, to the column itself. When in doubt, there is no harm. So let me put it this way. There is never any harm in running your code, especially in Jupyter Notebooks, when you're just running independent individual snippets of code. Just run it as many times as you want to actually see what happens. This is a great way to understand, hey, Disney, well, let me just leave that as is, create one more cell for this. Like, I like to learn by committing errors. So when I run my cell, I like to see what does it look like in this format? What does it look like when I do is GroupBY? What happens if I don't run it? That doesn't look right. What happens when I run it as a function? That throws an error. Look at what I've learned. I have to supply one of by or level. So this actually needs me to include something. So if I run this, let's say I want to group this by gender, and I just run it. Oh, that's interesting. Now I learned that gender GroupBY identifies this object as a data frame. So what do I need to get information from a data frame? Well, I need my number of minutes. Oh, this is interesting. This runs consistent. This runs and interprets this value as a series. And now I know that this is a series value. I can actually just apply an aggregated value. That's just summing up all the numbers. Let's try using something that actually makes sense. Mean, Yeah. And count. As you can see, this is a function that returns the count of how many values per minutes. You'll notice that this is exactly the same result as Disney. Gender, value, counts. Same value. All right, cool. Let's talk a little bit about tidy data format. Tidy data is really mostly a philosophical concept where in order to apply mathematical components or in order to apply some of the algorithms that we're going to be working in Python, it helps to understand that Python and a lot of the linear model and a lot of the types of models that we're going to be working with need your data sets to be structured in a very specific format. In other words, sometimes looking at a dashboard or looking at a data set, the way that is easier for humans to interpret does not necessarily mean that it's the easiest way to interpret for a machine. So generally speaking, the definition of tidy data refers to where every column in a data set has a value and every row has its own value on its own. So it tends to be a little like the larger philosophical definition behind this is a lot more complicated. And if you want a really deep scientific detail paper on this, this paper is actually fairly good, but it is an academic paper. But when we're talking about tidy data, we're referring to a data frame that includes records and values in every single observation and unique measurements for every single operation. So I'm going to quickly grab a data set just to show you what an example of this looks like. Yeah, I'm just going to go ahead and create this. And I'll share this with you on Slack so that you can see it. All right, so you can use that if you want to play around with it. So this is a data frame that I've just created. So that's untidy. Now, you and me as humans look at this chart and it becomes easy to interpret. Here are 3 students in which there were 3 quizzes applied to each student. So quiz 1, Maria did not pass or did not actually take the quiz, but Maria did, got a 90 on this course, and Maria then got a 95 on the next course. Connor did 75, 80, and 70. They were present for all sets of the quizzes. And then Win here was present for, got a 70 in that first quiz, was not present for that second quiz, and then was present for quiz 3. Great. That part makes sense. You and I can read that fairly interpret that fairly easy. The problem is that when it comes to a linear equation, these values don't actually match up in a way that they can essentially be that they exist as individual or unique values. So they can be a little bit more complicated to interpret. So every so often, and for the most part, at least in unit 1, you're not going to be working with data sets, or I'm not going to be giving you data sets that need to be untidied or need to be organized into tidy data format. This is really just for your own understanding of what tidy data looks like. But one of the methods you can use for easy cleaning of a data set is actually present for us. It's called the melt function. The melt function will literally unpivot a data frame. This is what's referred to as a wide data format, because the values that are important to us for our calculations are set in a wide format. So you would want these formats to essentially be their own column. So if you look a little bit deeper at the definition for melt, it essentially asks you to specify what ID do you want to use as your priority column, and how do you prioritize that value into long format. And it, for the most part, works really well at identifying and specifying all of the values into their own individual column. So because my focus is on the learners or the students themselves, I'm going to ask the melt function to unpivot this data along the name column. And when you run that, you see that it actually does most of the hard work for you. And this is a little bit more of a tidy data format, where the name of the column is every individual value is its own unique value, or its own, like every column has a unique measurement. In other words, the measurement for this column is all the names of the learners or the students. The variables are all the names of the quizzes, and the values are all the scores on those individual quizzes. And then every row is a record of a single observation. So this Maria's quiz 1, here's Maria's quiz 2, and here's Maria's quiz 3. Don't worry too much about this. This is just so you understand what we're working with when it comes to working with the difference between wide format data and long untidy or long tidy data. This is mostly a philosophical concept that you'll only need to address if you're working with, Excel or other visualization services that have a data set mostly in wide interpretable format. Just note that if the question ever comes up, what does a computer read better, this version or this version? It's obviously going to be this version. All right. With that, folks, it is 11 o'clock Pacific Standard Time. For the first time in 3 days, I technically am done on time. So congratulations, Julie. I'm just going to go and pat myself on the back for that one. So folks, this is all you need to know for your assignment today. But what we've covered is essentially understanding what to do with data that's coming from either different sources. Let me go ahead and share my music preferences there. Taking data sets from different sources and combining them in methods that work more effectively for us. We've also addressed how to aggregate and use categories within the data set to come up with additional processes of our EDA. Tomorrow, we're going to be diving into visualizations. We're going to be using 2 libraries, Matplotlib and Seaborn, and maybe a couple of others, whatever else I can find, to essentially understand the last step of our EDA process. Where understanding more from our data set doesn't just come from looking at numbers, but it comes from actually visualizing those numbers. So with that said, good luck on your assignment today. I'll be available for questions in about an hour or so after this period of time. I would like to address 2 of the questions that came up. One is what happens if there are 2 data sets with columns in common. So for that, I'm simply going to just show you how it works, because I don't have a data set ready to go for this. But I'll leave this here at the very bottom of this notebook. But if you have a data set that is, let's see, orders, there's that data set. And orders products. Orders and products. Well, actually, this might work. So let me just check here. So orders and set. Yeah, perfect. Okay, so this isn't going to come up in this format. This is just kind of for exercise purposes. Now let's presume that we want to combine this orders and products. Let me be very clear. This is a duplicative data set. Most of the values are already going to be the same. But if you wanted to combine both columns on the same, like under the same merge, orders.merge, orders and products, the table or merge will automatically default to merging along all the same columns. So we'll understand that it needs to combine under days since prior order, eval set, and ordered out. It'll do its best to combine all of the values that are present together in both data sets. And it'll try to combine as many of them as possible. This is not necessarily the best method, because sometimes you want to be very specific about along what value you're trying to combine along. So order ID specifies your column. And as you can see, when you combine order ID, it specifies and brings order ID to the very forefront, and it tells you you've decided to merge these two tables along order ID. But note that all of the duplicative columns now have an X and a Y variable applied. That's because order ID might have two different present values in the data set itself. This is merge trying to do its very best. What if, for example, I want to merge on two different columns? This one's important. Say I want to do order ID and user ID. You'll see that user ID and order ID are the two columns that are merged together. All the other values that are present get joined along those same values. This is one of those scenarios where I would want to specify that in orders and products, just to keep it a little bit cleaner, I just want order ID and user ID. That's supposed to be a list. Yep, that's supposed to be a list within the data set. So that's a little cleaner. Again, this is all about how you choose to join and combine your data sets and like what your priorities are when you're combining those two data sets, one after the other. One more thing. I can talk about this forever, so I'm just going to be as careful as I can. Say, for example, you have a situation where you have two data sets with the same column. But for example, let's say, I'm actually just going to go ahead and do this for us. Orders, we set up orders. Then it was, let me leave that there. Let me actually just leave that there. Does that still run? Yes, that's still. Okay, that works. All right, I'm going to leave that there. And then I'm going to take orders and products. Orders dot merge products. All right, does that work? Yep. Interesting. Look at that error. No common columns to merge on. That's because orders and products. There we go. That is merged. What did it merge on? It merged on order ID. What happens if, for example, we just happen to have order ID in orders and products, but under the products table, order ID is known by a different name. Let's take a look, for example. So here's products. Here's the products table. Whoops. Product ID. Product ID is the table we're supposed to be joining on. Sorry, folks. Let me correct. We're merging on product ID. Let me add a value to clarify that. Ugh. Set orders and products and set products. Let's print that out so that it actually displays so that we can refer to it. Product ID. Okay, so let's say, let me correct myself. Let's correct that products, that the column for products ID is something else, and it just happens to not be the same name. Let's actually go ahead and rename that column. So rename, and this is a fun little function. Columns requires you to specify the value that you're trying to rename. I want to rename product ID to product. Invalid syntax. That's supposed to be a dictionary. That's a dictionary. Cool. So there, I've just renamed my column. I'll share that with y'all. Who's interested in renaming your columns down the road. So now we have 2 data sets with different products name. I'm going to go ahead and make this change in place for myself. And now I'm going to try doing this same line of code below. Let me go ahead and do the hashtag. The set doesn't work because there are no values to combine together. If I try to combine it, no common columns to perform merge on. Merge options, left on, right on. That's fairly straightforward. I just need to specify that I am trying to change my values left on, product ID, and right on, product. And we see we get the same result that we did above. And you'll see it keeps the last name in the process. All right. So with that, I've addressed most questions you might potentially have come up in any kind of real world scenario. This is going to come back up again when you work with SQL. But in the meantime, that is technically all the content I have to teach you all today. So have a great lunch. Good luck with your assignment. And if I don't see you in office hours, I'll see you later tomorrow.
Thank you.
Yeah. And Austin, if you have a question, this is the time. Or if you want to bring it up, this is the moment to do it.
Okay. You said office hours starts at noon?
Sorry,
time?
2 p.m. 2 p.m. Same time
2
every
p.m.
day.
Okay.
Yeah.
Okay, so I have 2 questions, and the first is more something finally clicked, but I want to make sure I'm correct on this. So for method chaining, whenever we run a method on, I'll keep it simple, I'll say a data frame. Whenever we run a method on a data frame, it returns a certain data type. Might also be a data frame, might be a series, but it returns a data type, a new data type. Any successive method chaining that we do, the next method has to be a method that can be run only on that previous data type.
That's absolutely,
okay.
Yes, absolutely correct.
Is that, and that's consistent across Python. That's not just pandas, right?
Yes.
Okay.
Yeah, remember that
Okay.
pandas is technically a Python library, so they all work essentially the same way. So if we take a list, for example, so here's a list of 1, 2, 3. This is a list of integers. So let's say I create a set of values that has 3, 3, 1, 2, 2, 1, 3, or however you want to combine it. This is a set of lists. A, B, C. I'm purposefully making this confusing, clearly. Inside that list, we have 4, 5, 6. So this is tricky because here we have this whole thing, this whole object. I'm just going to call this an object. If you look up the type of object, so you're absolutely right. This is a list. But if I were to start indexing through these values, so say I want to get to this object in here. So that's 0, 1, 0, 1, 2, 3. You'll see that this returns a tuple object. I don't know if I said something differently there. So this tuple object is its own object. But even within that object, there are other items. So for example, there's this list in that first position. This is essentially this object included in here. And if we printed it out, rather than looking at the type, you'll see that this is the new object that's been created. So if I take that same object and I filter a little bit deeper, say for example, I want to get that first item, that's 0. That item is a list. Let's get to that I actually want to see if I can get to that second list. That second list is a list of strings. And if I go deeper, where if I want, for example, that first object, that is a string. And you can determine that by just checking the type. But note that this whole kind of breakdown is this 0 is building on top of the previous object. This index method chaining is exactly the same thing as indexing, in the sense that you are applying, just like you said, a method that applies to the object that we've created the most recently. That's a series. What's interesting about short values is that when you create an object with short values, this is still a series. So ordered day of week is a series, and so is sort values. So you can technically do sort values again. Doesn't do anything, but it's something you can do. From those sorted values, I can do value counts. I don't know what I would do that with, but it doesn't necessarily make sense. But you're still creating, like you're still like method chaining works really well in pandas because most of the functions essentially just create other series. So you're working on a series on top of a series on top of a series. This is not good practice, but other questions?
I have one real quick. If you scroll back up to the tuple where it says 4, 5, 6, is that considered not a list because there's no square brackets around it, or did you forget just to add the brackets?
Oh, this is these are 3 individual integers inside a tuple. Sorry, I created this really quickly. So this is part of the tuple in here. And so these are objects. These are just random objects inside these are random integers that are part of the set. So yeah, you can create this as a list if you'd like. I might have misspoken. By the way, if things are getting a little hectic, backslash at key points allows you to break up your code a little bit. All right, I'm gonna go ahead and stop the recording. Okay, so Austin and Logan brought up a really good point. Things that something that I missed here. So problem was, so where did 15 values go? I brought this question forward and then I used incorrectly here. I used the len method to quantify this value. So you're absolutely right. There is an error here. This is an error from class. So note that len order counts. Len counts. Len is going to count the number of rows in a series. So for example, if I take this and I look at the shape. No. Can I do that? Oh, yeah. Just set. There we go. So shape is going to count the entire number of rows in the series or data frame. In other words, there are 157 rows in this data set. So len is incorrect to use. Sorry about that. I'm gonna go ahead and just leave that there so that we see the practice of it.
That's
what
because
let-
it's also counting all the false values, right?
correct. That's correct. So good, great catch. So order counts equals 1. Thank you. Good catch. So it counts all the falses and all the trues. So this is the correct method to specify how many values, what they ordered when they ordered one thing. And yes, so when you count this, go ahead and do the shape of that. You get 142. Good catch. Shape. That. Back here. Cleaning this up for your notebook. Yeah, thank you. That is a great catch. I'll go ahead and put a correction on the Slack channel once I submit the recording. Other questions? Cool. I'm starving. I'm going to go to lunch and I will see you all a little bit later. Thank you so much, folks. I had a good time with y'all.